My name is Hannes Mock. I'm working as a senior design engineer at CISC Semiconductor, and I'm also very active in standardization. Here I'm chairing the wireless charging task force within the NFC forum, and I've also the honor to be the editor of the wireless charging test specification. At CISC, we are proud that we have a passion. We have a passion for providing trusted hardware and software communication solutions to empower our customers to develop products for seamless connectivity. Coming to some general facts about CISC. CISC was founded 22 years ago. Within this time range, we successfully finished over 700 projects with our customers, and we are operating in 120 countries. We are in general very active in standardization, especially in the RFID sections. Here, the most important group for the NFC wireless charging is the NFC forum. For us, it's very important to be active and to contribute actively to those standardization organizations, because this means you are in the first row if there is any new things popping up. This means we can hand over this future development and breakthroughs also to our solutions, and we give this back to our customers. In the area of NFC wireless charging, we want to also mention here that we are a gold partner of NXP Semiconductor. Where you can find us. So our headquarters is located in Klagenfurt, and we have a R&D office in Graz. This includes also an NFC interoperability lab. Both are located in Austria. We have also a subsidiary in Brno in Czech Republic and a sales office in the US. Further, we have a good network of distributors and sales partners all over the globe. Now jumping into the hot topic for today. So what is NFC wireless charging? So NFC wireless charging is advancing the standard for wireless charging application. This means that the NFC forum is targeting a coexistence to already existing wireless charging standards by addressing different applications. So here NFC wireless charging is operating at the 13.56 megahertz band and uses magnetic field resonance for power supply. The big advantage of wireless charging is that you can use the communication capability and extend those ones simply by a wireless charging functionality. Originally, NFC wireless charging supports energy harvesting for less than 100 milliwatt. And now with the help of the NFC forum wireless charging specification, it is enabling higher power rates. Now take a closer look what is currently within the NFC forum wireless charging specification itself. So as already mentioned before, the wireless charging specification extends the communication functionality of NFC technology to enable wireless charging. Here the NFC forum specifies two different modes: a static wireless power transfer mode and a negotiated wireless power transfer mode. Within the static wireless power transfer mode, standard RF field strengths are used and no parameter negotiation is possible. Whereas for the negotiated mode, parameter adjustment, parameter negotiation is possible. Having said this, in the negotiated mode, we are also allowing to exceed certain limits which are currently defined in the NFC standard by targeting to 4 power classes. Those 4 power classes are always reflecting the guaranteed received power. In numbers, these are 250 milliwatt, 500 milliwatt, 750 milliwatt, and 1000 milliwatt. As now wireless charging is able to deal with field strengths exceeding certain limits, The wireless charging specification defines proper mechanisms to guarantee safety during operation. With the so-called foreign object detection mechanisms, we are able to detect NFC-driven attacks or even also other attacks without any NFC communication capability. I want to also share some NFC forum insights with you. So the NFC forum has met each other during this week for the member meeting. I want to give you a brief update what is currently going on within the NFC forum wireless charging. The NFC forum is currently under preparation of the test specification for wireless charging to provide interoperability and compliancy within the wireless charging ecosystem. Further, we are also improving the existing NFC forum wireless charging specification, which was published last year, and improving those that we are able a more stable communication, a more stable power transfer, and also the reference equipment is updated to get a better performance. One hot topic in the NFC forum are the integration of smaller antenna form factors. Here, the NFC forum really sees a need on the market to the integration of such small antennas. This statement is also reinforced by the announcement of USI, so the Universal Stylus Initiative, and the NFC forum, that both are sharing the common understanding that NFC wireless charging is the technology to charge stylus pens. Now, coming to a comparison between one of the most popular wireless charging standards, the Qi charging, to NFC wireless charging. So basically, they were coming from two different aspects. Qi charging, which is specified by the Wireless Power Consortium, is strictly a power standard designed for wireless power transfer, whereas the NFC standard was mainly developed as industry standard for data transfer. Now, the Qi is working at the frequency of 100 to 200 kilohertz. By this low frequencies, Qi relies on tight coupling. And the power of Qi is quite good, so it delivers 15 watt, which is currently specified for mobile devices. On the other hand, we have the NFC forum standard, or the NFC forum wireless charging standard. This one operates at the frequency band of 30.56 megahertz. To this higher frequency, it not relies on tight coupling just anymore. This means we are also allowing loose coupling. And with this coupling, you have more freedom of placement, as you may know from any payment application. Further, also a big advantage of NFC wireless charging are the higher data rates. Here, compared to Qi charging, which comes with 2 kilobits per second, NFC allows 106 kilobits per second and even more. And one of the biggest differentiator are the coil sizes. So here, NFC can really be used if you require a small antenna form factor. Coming now to the system architecture. So how an NFC wireless charging system basically look like. Fundamentally, it's similar to any other wireless charging system by simply adding NFC control to those ones. So we have a bowler emitting RF energy, and this one is used by the listener. The bowler can be quite easily described by two components. So we have the transmitter. This one integrates already the microcontroller and the NFC controller. And we have this interface, the antenna. The listener uses also an antennas interface. And now we have here two receivers in place. We have the NFC receiver, which enables the NFC communication, which is following the wireless charging protocol. And we have a power receiver. Here we mentioned the charge controller. So the power receiver is converting the RF energy into DC power, and the charge controller is used for a stable charging of the rechargeable battery. The whole system here is also controlled by a dedicated microcontroller. Having now seen the architecture, I would also like to give you a short overview about basic operation states of an NFC wireless charging system. At first, we have the NFC link establishment. The NFC link establishment is used here that the wireless charging poller establishes the RF link to his counterpart device. Within the next state, the wireless charging control activation, the wireless charging poller identifies if the counter device is a wireless charging listener and wants to get charged. If it is so, the wireless charging listener also shares his capabilities, which modes he's supporting. Here we heard before, we have the static and the negotiated mode. If we now support the static mode, we go directly into the static wireless power transfer phase. Whereas if the negotiated mode is supported, there are parameter adjustment and negotiation takes place, and this one is done into the wireless charging control phase. If now the system has agreed on certain parameters, the negotiated wireless power transfer can take place. Here we have enabled a background foreign object detection as we are dealing with higher field strengths as currently limited in the NFC standard. Take a look for which products NFC wireless charging is suitable for. So here in general, we can see most of them has a pretty small form factor. Talking now about earbuds, stylus bands, augmented reality glasses, wristbands, key fobs. So here really they share one together a really small form factor, and this is what NFC Forum is targeting for, to enable wireless charging for small form factor devices. A further big advantage is here that we are also targeting sealed devices where you are operating in a harsh environment and you have to seal your device. This is maybe for industrial sensors and so on. So what challenges are those products bringing to a wireless charging system, and how NFC wireless charging is solving them? All of those products, as mentioned before, are targeting a really small form factor. This means a small form factor because there are space constraints, and the small form factor brings also with that you have to design smaller antennas. And here, wireless charging brings those capability to do so. If we compare this with G charging, you will be not able to design antenna in an area of 10 to 5 millimeters approx. And also big point is cost-effective designs. And here we also targeting already products which have an NFC communication capability inside by simply adding our wireless charging, also using the NFC channel. A moderate charging time is also given in the fact if we now see a 100 milliampere battery can be quite easily charged within 1 hour. As also mentioned introductory, so NFC relies also on loose coupling, which means you have a lot of more freedom of placement. Here, the user experience is extremely improved because you are not have to place your device on the exact position all the time. And as NFC is coming from the data transfer aspect, reliable communication is given. The lower cost of ownership is also a quite important topic for products. So this means you can lower the cost of ownership by removing like connectors and so on. And also this comes with, you're able to design with NFC wireless charging sealed devices which are able to communicate over the NFC interface, and also they can be able to charge via the NFC interface. And also one big point is that they are now standardized in the NFC form, which means with a standardized product, you can be interoperable on the market. So NFC wireless charging are emerging technologies where CISC has been involved since its beginning. So this utilizes more than 20 years of RF knowledge that we provide to our customers. Our experience is also built on seeing failures on NFC designs during our test sessions, our lab, and we are continuously working on overcoming those ones. Today, I want to cover some of the most seen traps which we have identified during the develop NFC wireless charging system. Here, first aspect is hardware design. Really, don't forget the RF aspect. One of the other key points is focus on high power transfer efficiency only. For sure, power transfer efficiency is the key for any power system, but there must be also the capability to communicate. A metal environment, is it now really always bad for our system? And also, does a small form factor, what NFC form is targeting for, always means less power? Coming now to the first aspect, so the hardware design. Ignoring here basic rules can really lead to huge issues resulting on a long debugging time, higher costs, and a delayed market introduction. Based on issues we have identified during our test sessions, we clearly recommend to separate the data lines from the RF lines, especially now also for wireless charging, we are using much higher field strengths. So here it's even more important to clearly separate those ones. For reducing losses and to avoid any thermal issues, we have also clearly one recommendation that you should increase your direct width on the RF lines and also to come up with a proper copper thickness. Here at least we are targeting 35 micrometers. An important point also are in general thermal issues on your design. So to overcome this, quite a simple fix can help you. So use really multiple wires to connect your ground plane. This can help you to overcome thermal issues. On the bollard design itself, you should place the MC filter, if this one is required for your design, as close as possible to the NFC transmitter. This helps you to really to overcome certain EMI issues in a later stage. For the listener design, it's nearly the same as I mentioned for a bollard design, but just adding that the matching and tuning structure should be really compact, placed, and also not too far away from any RF circuitry. Now, focusing on high power transfer efficiency only. Here, really, this is a quite important topic for NFC wireless charging design. So, because for such designs, we have to find a trade-off between data integrity and power efficiency, which means with a high-Q system, it is possible to design a low-loss power transfer solution, whereas with the low-cost system, you prevent the attenuation of your sideband subcarriers. Now, a low-Q system allows you a stable communication, but this means you have less power in the channel. And now the really big thing is for wireless charging systems that they have to be designed in a way to taking both aspects into account. So really consider those in your designs. What is also quite an interesting topic is metal environment, and shielding. So is metal now always bad for your design? So in general, we can assume that metal has an impact on RF performance for sure. If we take a look on the picture on the upper right side, we see an antenna without any foreign material nearby. This means we have also a good field distribution. The red color indicates here that a high magnetic flux is going from the Polar coil on the lower side to the listener coil on the upper side. Here we see quite a stable energy transmission. Comparing now this with the figure on the lower right side, we see that there is a metal plane placed below the polar antenna. And those metal plane prevents the magnetic flux, or especially the eddy current within those metal plane prevents the magnetic flux passing over the polar antenna itself. We see here that nearly no field is going into our listener design. So here we have a really bad performance. Now, how this can be overcome? So in general, ferrite shielding is a good way to do so. By the use of a ferrite shield, you can protect one's quite sensitive components on your designs. And also ferrite shielding helps you to overcome issues with a metal nearby your antenna. So ferrite shielding, we see this in the middle antenna and the middle figure, has nearly no influence of the overall RF performance. So it's more, we are directing the field in the right direction. Okay. But now coming back to our initial topic, is now metal always bad to your system? We have seen in general, yes, it is bad, it reduces your RF performance, but with a proper shielding, you can overcome these issues. And further, I want to add here that metal is also not always bad if you like to operate in a metal environment, which means in a metal environment, a metal case around your antennas can help you to eliminate the detuning effect there. Coming now to the next point. Does a small antenna form factor also means less power? Here, a key advantage of the NFC wireless charging is smaller form factors of the antenna compared to other wireless charging standards. But does this now really mean that the antenna is not able to go with high power? First, let's differ between power efficiency and the maximum power. For the efficiency, multiple benchmarking aspects must take into account, like the coupling factor. Here, the coupling factor gives us a good indication about the power transfer efficiency itself. Generally, it can be assumed that the well-aligned polar and listener antenna with a good overlap result in a high coupling. Here we have a recommendation that a system should have a coupling factor above 20–25% to see quite a proper efficiency in terms of charging. What we also know is that the Q factor of the system has an impact on the power transfer efficiency itself. So a high Q system or a high Q antenna has quite a good RF link performance. On the polar side, the Q must be limited, as we already know, to allow a stable communication. We recommend here an overall Q below 4D to allow really sufficient power in the channel, but even also to allow a stable communication. On the other side, you should also keep the listener Q factor low. This is because you would like to limit the transfer impedance that you're still able to tune your board design or your complete system in a proper way. As I've also already indicated, the distance between the antenna has an influence on the efficiency performance. We see here on the figure on the right side 3 different form factors of coils, and we also clearly see that by increasing the distance, the efficiency drops. This has more impact on small antennas compared to larger antennas, but in general, increasing the distance, your efficiency will drop. Here we have also clearly one recommendation. So if you're dealing with larger distances, you should increase your antenna form factor slightly compared to the listener. So you should increase your antenna form factor if your distance is increasing. This can help you to overcome certain issues. The antenna form factor itself, we pretty see here also on this figure, then the efficiency, if we keep the distance fixed, like here for 2 millimeters, we have here quite a stable power transfer efficiency, also for all antenna form factors. So concluding now on this, form factor has a minor influence on the power transfer efficiency itself, if the distance is not stable. But in terms of maximum power, which can be transmitted, here the form factor has an influence. Because you will be not able to design small antennas with huge drag width so you have to go down to thinner drag width, and a thinner drag width means you have increased your losses. Increasing your losses means you will have thermal issues, and even the smaller drag width will not sustain high fields. So therefore, yes, we can assume that the small antenna form factor lowers your power, but in terms of efficiency, here we see nearly no impact. Having now talked about the traps we have seen or during our analyses, coming now to the topic what CISC is offering. CISC is offering a one-stop solution. This means we are going from feasibility studies, prototype design, development of OEM models, and full production support and consulting, and also including here global certification. We are very proud at CISC that we have the complete know-how in-house, from designing hardware, firmware, also this confirmed to international standards, but also advancing those standards. Especially for NFC and NFC wireless charging, I want to point out that CISC is providing NFC wireless charging, we call them technology elements, for a reliable integration to customer designs. By use of our fully tested technology elements, our customers can benefit from a faster time to market. With the use of this NFC wireless charging technology elements, CISC is also advancing the standard by enabling fast and simultaneous charging of multiple tags at once. The technology elements in general are providing a set of hardware blocks and firmware libraries. Both are well tested and reliable, and also multiple antenna design with various form factors for reliable integration into customers' products and applications. CISC has here also released an NFC wireless charging development platform to allow customers evaluating and analyzing wireless charging and their needs. The development platform of CISC supports here different antenna form factors and is based on our modular approach to achieve a faster time to market here as well. We at CISC looking forward to supporting you in the area of NFC and NFC wireless charging. And with that, I want to move to Q&A.